Hello everyone, welcome to my presentation. I am dealing with the subject Power Plant Engineering. In that, my topic is dust collectors. The outline of my presentation is dust collectors, classification of dust collectors. In that, first one is dust collectors. The products of combustion of coal, fires contains particles of solid matter floating in suspension. This may be smoke or dust. If smoke, the indication is that combustion conditions are faulty and the proper remedy is in the design and the management of the furnace. If dust, the particles are mainly finely ash particles called as fly ash intermixed with some quality of carbon ash materials called as cinder. Pulverized coal and spreader stoker firing units are the principal types causing difficulty from the source. Other stokes may produce minor quantities of dust be generally not enough to demand special gas cleaning equipment. The two mentioned are troublesome because coal is burnt in suspension in a turbulent furnace atmosphere and every opportunity is offered for the gas to pick up the smaller particles and sweep them along with it. The size of the dust particles is measured in terms of microns. 1 micron is equal to 0.001 mm. The microns is the 1 millionth of meter. As in the indication, if the jet is allowed before the grate, the air is forced through the fuel bed, furnaces and the fuels to the chimney. The principal characteristics of the ash collectors is the degree of the collections. The following are the principal characteristics of the fly ash: density, dispersity, electrical resistance, clearance of ash particles. Dust particles are broadly classified into two types: mechanical dust collectors and electrical dust collectors. Mechanical dust collectors are again broadly classified into two types: wet type dust collectors, dry type dust collectors. Dry type dust collectors are again broadly classified into two types: gravitational separators, cyclone separators. Electronical dust collectors are again broadly classified into two types: rod type and plate type. So these are the different types of the dust collectors. In that, first one is mechanical dust collectors. The basic principle of mechanical dust collectors is shown in the figure. There are three principles here. Principle A, B, C. In the first one represents the enlarged cross-sectional area to slow down the gases, gives the heavier particles to settle down. So as the area is very large, the gas particles and the heavier particles will settle down easily very fastly. And the second basic principle represents when a gas makes a sharp change in flow directions, the heavier particles fit to keep going in the original direction and they settle down easily. So these particles, heavier particles settles down and the lighter particles will move upward direction. In the figure C represents the impigmentation baffles. So here baffles are used and have more effect on the solid particles than the gases. And the baffles help the solid particles, that is heavier particles, to settle down and the lighter particles will move in this direction. So these are the three principles used in the dust collections. And second one is the wet type dust collectors. So mechanical dust collectors, wet type. Wet types are also called as scrubbers, operate with water spray to wash dust from the air. Such larger particles of the wash water are needed for certain station gas washing that this system is seldom used. It also provides a wastewater that may require chemical neutralization before it can be discharged into natural bodies of the water. So wet type dust collectors are again broadly classified into two types. This is the wet collectors, dry type collectors. It is commonly used as a dust collectors. Dry type dust collectors are again broadly classified into two types: gravitational separators and cyclone separators. In that, first one is gravitational separators. The cyclone is a separating chamber wherein high-speed rotating is generated for the purpose of centrifugal the particles. And coming to gravitational separators, the collectors act by slowing down gas flow so that the particles remains in the chamber long enough to settle down in the bottom. They are not suitable because of larger chamber volumes are needed. And this is the second type, cyclone or centrifugal collector. The cyclone is a separating chamber wherein high-speed rotation is generated for the purpose of centrifugal the particles from the carrying gases. Usually there is a downward flowing vortex, which in turn in inward flowing vortex. Inlets and sufficient velocity head pressures are used to produce the particles. As the multiple small diameter vortices with high pressure drop appear to have cleaning efficiency, that type is now being exploited. Skimming cyclones shave off the dust at the periphery of the vortex along with the small portion of the gas flow. This concentrated flow is then led to a secondary chamber for the final separation. The factors which affect the performance of this collector are gas volume, particulate loading, inlet velocity, temperature, diameter of height ratio of cyclone and dust particles. And advantages of cyclone separate dust collectors are they are rugged in construction, maintenance costs are relatively low, efficiency increases with increases in load, easy to remove bigger size particles, and disadvantages are requires more power than the other collectors, incapable to remove dust and ash particles which remain in suspension still air. And the cyclone separators are less flexible in terms of volume handle. Higher pressure flow comparatively from 2 cm to 15 cm of the water. Requires considerable headroom and must be placed outside the boiler room. As the thickness of the duster particles increases, its collection efficiency decreases. And next one is the electrical dust collectors. So basic example of electrical dust collectors is electrostatic precipitators. If it has the two sets of electrodes, which includes from each other. The maintain of an electrostatic field between them at high voltage. The flue gases are made to pass through the set of electrodes. The electric field ionizes the dust particles and that passes attracting them towards the electrode at the opposite side. The other electrode is maintained at a negatively potential of 30,000 to 60,000 volts. The dust particles are removed from the collecting electrode by wrapping the electrode periodically. The electrostatic precipitators is costly but has low maintenance and is frequently employed with pulverized coal-fired power station, and its effectiveness for a fine ash particles and it's superior to that of other type. A electrostatic precipitator having the following components, that is the source of light and ionization and collecting particles, dust removal mechanism and shell to house reports. Gas conditioning. Gas conditioning is the injection of small quantity of SO3 into the flue gases. This reduces electrical resistivity of fly ash and thus makes the dust more empurable for the collection than in the electrical precipitators. Thus, it increases the collection efficiency of the precipitators. And advantages are they can effectively remove small particles like smoke, mist and fly ash. They are easily operated. Draught loss is quite less, more efficient for high dust loaded particles. Maintenance charges are minimum. The dust collected in dry form and can be removed either by dry or wet. And coming to disadvantages, space requirement of the electrostatic precipitators is very more. Need to protect the collector from sparking. Running charges are very high and the capital cost of the equipment is very high. And if you want to replace one part of the electrostatic precipitators, we require more cost. And the efficiency of the dust particles. The efficiency of the dust particles is shown given below. The collector efficiency of the dust particles is the amount of the dust removed per weight of the dust. Thus, dust collectors remove contaminants, they increase draught losses and hence the fan power. The absolute efficiency of the dust collector is the percentage of entering of the solid particles removed by the collector. Some manufacturers prefer to rate their equipment on efficiency curve. So these are the efficiency curves. So if we plot a graph between the particulate size and percentage of dust collected, particulate size units is microns. We previously discussed. And there are the three types of the dust collectors: cyclone, Lovier and electrostatic precipitators. So electrostatic precipitators will removes the dust particle size from 10 to 100 microns, whereas lower dust particles will remove the dust particle size from 0 microns to 70 microns, and the cyclone separators removes the dust particles from 0 microns to 45 microns. So electrostatic precipitators will remove more dust particles when compared to the other particles. And their combined operations of the dust particles are also there. Combined cyclone and baghouse collectors, combined dry mechanical and electrical collectors, combined wet mechanical and electrical collectors. This is the layout of the ash handling and dust collection systems. So in this block diagram, we represent both ash handling and dust removing systems. So if we take this block diagram, if we take this furnace, from the furnace, the molten solid ash is there. The solid ash can be removed by the systems of mechanical system, hydraulic, pneumatic and steam jet systems. From this, the ash is collected in ash bunker or ash pits or settling tank. These ash can be transported by using railroad cars, motor trucks and garbage, and from that they are used again for recycling for road construction, disused quarries, deep ponds and for the brick manufacturing. This is the final disposal method. And from the furnace, if we get the molten slag, that is in the form of the dust, soot and fly ash, it is collected in the dust collector, and the dust collector techniques can remove the dust, and it is again sent to the chimney. For the removing of the dust particles to the chimney, we need an external source, that is we use the fan for a higher removal of the dust.